Welcome to another video in the Visual COBOL for Eclipse in a Nutshell series. In this video, we'll take a look at getting your Docker-based COBOL application deployed beyond the Eclipse development environment. We'll explore prerequisites and background for this demo, how to build a final Docker image that's intended for deployment beyond the developer's workstation, and finally, we'll look at the steps to deploy this Docker image onto another Docker host. For example, to an integration testing, QA, or production system. The information in this video assumes that you have the required products installed and licensed. These include Visual COBOL for Eclipse is required to build a deployment image from the Eclipse IDE. You can find information about installing and licensing Visual COBOL for Eclipse, as well as how to use many features of the product in the YouTube playlist, Visual COBOL for Eclipse in a Nutshell. The demo requires that the product Visual COBOL Build Tools for Docker for Windows is installed and licensed. And because we'll be creating a Docker image meant for deployment to post-development environments, the COBOL Server for Docker product must also be installed and licensed. Details on installing these products are covered in the YouTube video Installing Visual COBOL Support for Docker, also available in the above playlist. This video assumes that a COBOL project has been configured to work with Docker. Details for configuring the project are covered in the prior video, Developing COBOL Applications for Docker and Eclipse. This video focuses on the steps to build a Docker image and to deploy it. A subsequent video will cover how to debug against a Docker application after it's been deployed beyond the developer's workstation. The demonstration in this video uses Visual COBOL 6.0 with native COBOL. The steps are slightly different for working with JVM COBOL and Docker, and these are covered in the documentation. Also, many of the features shown are new in version 6.0. So you won't find them in earlier products. First, let's look at a high-level overview of the deployment process. These steps assume that dev testing has been completed on the developer's workstation. Now you are ready to deploy your application beyond the development environment, so you'll need to build a deployment image. This can be done within the Eclipse IDE or from the command line. Then the resulting image can be labeled or tagged as required in your organization, and finally, the image can be pushed or deployed to make it available beyond development. Next, let's review a little background about the different types of Docker images that Visual COBOL for Eclipse can create. As just mentioned, a developer can initially build a COBOL application intended to run inside a Docker container and then debug it running locally within the Docker on their workstation. As a reminder, the steps for this are shown in a prior video, Developing COBOL Applications for Docker and Eclipse. When the debugger is launched in this mode, behind the scenes, a development Docker image is built on the fly. This development Docker image contains the tools, runtime, and licensing to allow local developer testing within a container. This is the default image type created for a project in the IDE. Once finished with dev testing on the development workstation, we can modify the settings for an Eclipse project to instead build a Docker image that is intended for deployment to another Docker host. After making this switch, an image created from this project will contain the deployment version of the COBOL runtime and licensing, and is ready for transfer to another Docker host. Before a demonstration of the process to create a deployment Docker image, let's walk through the required steps to do this in the Eclipse IDE and look at some helpful background information. Building an image for deployment is a two-step process. The first step is to change the properties of the project to request deployment images. This is done on the container pane within Project Properties by clearing out the contents of the Build Arguments field. To understand what this does, let's take a quick detour to examine the image build process. First, as mentioned in the prerequisites, building a Docker image for deployment requires that you have the COBOL server for Docker and Visual COBOL build tools for Docker products installed. The installation of those products is actually the creation of several Docker images, represented here on the right. The process we'll use to create deployment images for our application will make use of these images. In Docker, the creation of an image can be done using instructions within a Docker file. The prior video showed the steps to create a default Docker file for your project. Let's examine the contents of this Docker file. It's helpful to understand that the default Docker file generated by Visual COBOL uses a feature of Docker named multi-staged image build. This means that the instructions in the Docker file are carried out as a series of discrete steps or stages, and each stage can make use of the results of the prior stages. The stages of the Docker file begin with the word from. The first stage uses the arguments deploy base and dtag from above to specify that the installed COBOL server image should be copied to create a temporary runtime image. The as clause on the from specifies that this image is to be assigned the name base so that it can be referenced later in the Docker file. Because this image is for COBOL server, it does not contain the components to build an application, only the COBOL runtime. An additional workdir command within this stage specifies that the default present working directory associated with this image will be /app. The second stage creates another temporary image named build-env, similarly copied from the installed VC build tools image. This image contains the compiler and other development-specific tools. The additional commands in this stage copy in the project files from Eclipse and then use ant to execute a fresh build within this temporary image of the programs from the project. The third stage copies the temporary image from the base stage to create a final image for deployment. It then copies in the built objects from the build-env stage. Finally, this stage specifies that when a Docker container is launched from this image, the default action will be to immediately run the executable that was created by the build of the project, in this case named hello64dockerproj.exe. With that background, let's consider what we do in step 1 when we clear out the contents of the build arguments field in the project properties. That field provided a value for the deploy base variable, which overrides the setting we saw specified near the top of the Docker file. So by default, an image built by the IDE is a development image because of this build argument setting. By removing that setting in project properties, we allow the base image to instead be built from a COBOL server for Docker image, which is suitable for deployment. Step 2 is much simpler. We just right-click on the Docker file within the project and choose Build Image. Now let's see these steps in action in the IDE. First, I'll go to Project Properties and then to Micro Focus Project Settings Container. In this pane, I'll clear the contents of the Build Arguments field. By the way, if I discover at some point that I need to go back and do more debugging locally within a Docker container on my workstation, I can click the Restore Defaults button below to repopulate this field. I'll click Apply and Close to save my change. With the project settings changed, I can go ahead and request the build of the deployment image. I'll right-click on the Docker file and click Build Image. The build of the deployment image will take some time to complete. After the image build is completed, I can see the messages from Docker in the console view. In fact, the console shows a breakdown of each line in the Docker file being processed. These are listed as numbered steps. At the bottom, we see that our image meant for deployment was successfully built and tagged. Now that the image has been built, let's explore the image ID and tag that were assigned to it. From a command prompt with admin rights, I'll use a Docker images command with a wildcard to filter the resulting list and locate the newly created image. Within Docker, images are assigned a randomly generated image ID, but can also be labeled with a friendlier two-part name made up of the items shown in the repository and tag columns. The image built by our previous step was initially assigned a repository name matching the Eclipse project name and a tag with the word latest. A common convention when deploying Docker images for use by others is for the repository name to be set to reflect the name of an application and the tag to indicate the version of that application provided in the image. Before transferring my image to another system, I may want to relabel the image that way. I can do this with the Docker tag command. Suppose I want to indicate that this image is version 17.2 of an application that's known to the world as Hello App. I can ask Docker to also tag my new image this way. The first parameter is image ID for my image, or a current repository and tag for my image. This is followed by the new repository and tag name I'd like applied. Now, another filter Docker images command shows this didn't create a new image. Notice that the image ID of the two images listed is the same. I've simply created another reference to my deployment image, labeled with more descriptive information. As an alternative to creating a deployment image in the IDE, this can also be done with Docker commands at the command line. Briefly, the steps are: launch an admin command prompt, cd to the directory containing the Eclipse project, and execute the Docker build command referencing the Docker file within the project. When these steps are completed, a deployment image for this project has been created within Docker. Once your deployment image has been created, there are multiple ways to share it. However, it's important that before you distribute it, you make sure that you are appropriately licensed for this, and that your distribution complies with the product licensing terms and conditions. If you have any questions about this, please reach out to your Micro Focus account manager. There are many options for distributing an image. I'll touch on a couple of these. One way would be to push or upload your Docker image into a private Docker registry. Setting up a private registry is beyond the scope of this video, but you can find information about this on the Docker website. I won't demonstrate doing a Docker push as part of this video, but here is an outline of the steps involved. Once your registry is created, you would tag your image. The tagging is done differently in this case. The tag should reflect the details of the registry server you'll be pushing to, as shown here. Then you can use a Docker push command to push the image to your private registry. Once the image is available there, a Docker pull command can be executed on your target Docker host to download and install the image onto that system. Another option for deploying your image onto another system is to use Docker save and Docker load commands. This may be a simpler deployment process for a developer, and also works in situations where your target system may be on a network that is isolated from the development system. As a final demo, we'll try out using these commands. Once again, I've already tagged my image with the application name and version information. Now I'll use the Docker save command to save the image as a tar file into a directory I've created for this purpose. As with all things Docker, it takes a while for the image to be saved. Next, I can transfer the resulting tar file to the desired Docker host using FTP, removable media, or some other transfer method. Now I'll switch to the target Docker host where I've transferred the tar file. To make the tar file easy to locate, I placed it into a directory I created named Transferred Images. The Docker load command can now be used to import the tar file as a new image into Docker on this system. Let's use the Docker images command to confirm that the image is available and ready to run on the new system. As a final test, I can run the application inside the new image with the Docker run command, specifying the repository and tag names. I see the expected output. That concludes this video on deploying your Visual COBOL for Docker application to a system beyond development. In the next video, we'll explore how to debug a deployed Docker application. Thanks for watching.